All right, let's talk a little bit about confidence intervals. Okay, so when we say something like, make a 95% confidence interval for P, okay, and let's say our interval ends up going from 0.25 to 0.35, okay, we would then say I am 95% confident that the proportion P is between 0.25 and 0.35. Okay. What if I make a 90% confidence interval? What happens to our interval? Does it get wider? Does it get more narrow? What happens when we decrease the confidence interval? So if I make a 90% confidence interval, our resulting interval will be more narrow. Say, I don't know, 0.255 to 0.345 or something like that. Or, you know what, just forget that. I'm going to just exaggerate it, okay? Say 0.26 to 0.34. Okay, so if I decrease the confidence, our decreasing confidence our interval will be more narrow. Okay. Okay. So let's say this is our confidence interval, okay? Let's say I ask the question, do we have evidence against the claim that P is equal to 0.258? Okay, so at the 95% confidence level, at 95% confidence, 0.258 is inside our interval. Okay, so that means 0.258 is a plausible value. And we would say we do not have evidence against the claim that P equals 0.258. Is that okay? So when we look at the 95% confidence interval, we see 0.258 is in between here and here. Okay, what about the 90% confidence level? What happens? So at 90% confidence, okay, 0.258 is outside of the interval, right? Feels like I'm Cinderella. So at 90% confidence, 0.258 is outside the interval. So what does this mean? Yeah, so now we do have evidence. We do have evidence against the claim that P is equal to 0.258. And this might feel a little uneasy. You might say like, well, if you're looking at the same data, how can you say you don't have evidence against the claim that P is 0.258 on this case, and you do have evidence that P is not 258 in this case? Okay. Because all we did was we just shifted the confidence level, okay? And that's exactly what happens. If you're willing to be less confident, you can start saying stuff like, I don't believe, I have evidence against this claim. It's just the confidence in your statements get lower and lower and lower, okay? So you can start to reject certain values of P more easily, but you'll be less confident in that statement. Yes?
So for the same question, like, do we have evidence against the claim? If it were to say, do we have evidence that P equals 0.25, would the answer be no, because P is not like necessarily equal to...
Okay, so I'll answer that question in just a moment here, okay? But before I answer that question, I want to make sure we're okay with saying whether we do or don't have evidence against some claim that P is equal to something. Is this okay? And even though we're looking at the same data and we just decrease the confidence, our conclusions can change. Okay, so we had a good question that says, do we have evidence to support the claim that P equals 0.258? So using the same intervals, okay, and then let's say our 95% CI is 0.25 to 0.35. Okay. So what's our answer here? Do we have evidence to support the claim that P is equal to 0.258? And the answer here is no. Okay? We can never use a confidence interval to say that P is equal to a particular value. P is exactly equal to a certain value. Okay, all we can say is that this value of P is plausible. Based on the current data, this value of P is plausible. But it never says that P is going to be equal to this value, okay? We can say, based on the data, this particular value of P is plausible. But we can never say that P is exactly equal to some value. So basically, if the interval does not contain, and this applies also for μ's, so if a particular value of if p or mu is not in the interval, okay, we have evidence that the population proportion or mean is different. Proportion or mean is different from that given value. Okay. And then the contrapositive would be true. If a particular value of p is in the interval, then we don't have evidence that the population proportion is different from the specified value. How's all of this feeling? Is feeling okay? All right. Let me think what other things I want to say about hypothesis tests or confidence intervals. Oh, maybe some other general ideas. Increasing sample size will have what effect on our standard error? So increasing n will cause standard error to decrease. Yeah. Okay. What is the standard error? This is the standard deviation of what? Standard deviation of the sampling distribution. And when performing statistical inference, it's important that we know the kind of the variation that exists, because that will tell us if, here, I'll write this. When performing statistical inference, you know, we compare kind of the observed, the reality, versus the expected, right? Observed versus the expected. Okay? And that difference between the observed and the expected is deemed significant if it is much larger than the standard error, right? If it's like twice or 3 times bigger than the standard error, okay? So to decide if the difference between, you know, observed and expected is large, we compare it to the standard error. Okay, and so that's why, you know, our test statistics are basically z is equal to observed minus expected divided by the standard error. And so in this case it would be, you know, p hat minus p0 divided by the standard error. Or you have t is also observed minus expected divided by the standard error. And this would be x bar minus mu divided by our standard error. Okay. I guess for 2 sample z, you also have z is p hat 1 minus p hat 2 divided by the standard error. Okay. But essentially, we're just saying this is what I'm expecting, this is what I actually got. We compare those things, observed minus the expected. We get the difference between what we expected under the null hypothesis versus what we actually got. Is that difference significant or not? Well, we compare that difference to the standard error. If it's, 3 times bigger than the standard error, then that's a significant difference. However, if it's only if it's about the same size as the standard error, then that difference is not significant. Okay? And that's kind of all of this. I guess the course, if you want to summarize statistical inference in a single thing, that's effectively what we're doing. Our calculations of the p-value are based on this test statistic, which is the ratio between the difference and the standard error. Is that feeling okay? We feel like we've got a handle on intro stats? Maybe. All right, we'll find out, huh? Okay. Should I talk about conceptual stuff from chapters 1 through 6 also? Yeah? Okay. There's a lot in chapters 1 through 6, so, I don't want to say I'm going to cover everything here, but, okay, let's talk about, you should know kind of categorical versus numeric variables. I can't spell. Well, that was always my problem. Okay, categorical versus numeric variables. Okay, and you should know the how do we summarize categorical variables? What do we use? We have frequency tables, two-way tables, and bar charts. Okay. Numeric variables, what do we have? To summarize, what do we use? We have mean, median. These summarize center. We have the standard deviation and the IQR. And these summarize spread. And as for displays, we have histograms, box plots, and dot plots. When do we use scatter plots? Yeah, question. Oh, okay. Yeah, that's good. We'll put this on hold because that's related back to our inference stuff. Okay. One-sided versus two-sided tests. Okay, so this is regarding hypothesis testing, right? Okay, hypothesis testing. Okay, one-sided means the alternative has greater than or less than. For a two-sided test, this means the alternative has a not equal sign, okay? The null hypothesis always has an equal sign, okay? Null hypothesis always has equal sign. Okay? One-sided test, you know, in the question it will say, you know, do we have evidence that, you know, the population, whatever, population mean or proportion is larger than something, or is greater than, or more than, whatever, you know? All of these types of comparison words. Or less, or smaller, okay? All of these would turn into greater than, or is less, smaller, fewer, I don't know. If we're talking about heights, shorter, lighter, you know. You guys know how words work, okay? And then for over here, it would be like, do we have evidence that the population mean is different or has changed or is not the same, or, you know, similar type of things, okay? And so these would all imply not equal. Okay, and then as far as this affects how we select our p-value, okay, how to, if the alternative has greater than, our p-value will be what? Is the area to the right? Okay. Which means if you have a z, you're going to do 1 minus that. If you're dealing with the t-table, you just take the column headings, because the column headings right there say right tail probability. Okay? And on the other hand, if the alternative has a negative sign, then the p-value is the area to the left. Okay? Which, if you have a z-score, you just take the value given in the table, because the table always gives you the area to the left. For the t-table, if you have the alternative less than, then you're probably going to get a negative z. Negative z means you just change all the signs in the table to be negative, and then the top thing changes to left tail, and so it basically works out. Okay. And then if you have alternative equal to not equal to 0, what happens to your p-value? It's 2 times the tail area. Okay. Is the p-value for not equal always going to be more than the p-value for a one-sided test? No? When is it not going to be? So you could have a test where the two-tail ends up looking like this, but then maybe the alternative for if it was one tail could be like this. And in this case, the p-value for the two-tail is smaller than this, right? So that is possible. That is possible. All right, is this okay? I hope this is kind of reviewish. All right, so let's flip back, reviewing our chapters 1 through 6 stuff. Okay, do you remember our conceptual definitions for the mean and the median? What is the mean? Conceptual definition. And what's the median? conceptual definition. Mean is the balance point of our data. What's the median? The halfway point. Okay. Which one's affected by outliers? Mean, okay, affected by outliers. And this one is not affected by outliers. What about our measures of spread? Yeah. Oh yeah, I was going to talk about, okay, yeah, when do we use scatter plots? Scatter plots are for what kind of data? It has to be two numeric variables, okay? Two numeric variables. Okay. What does it mean to be skewed left versus skewed right versus symmetric? Okay, so know what those things mean. Let me think. Chapter 3, skewed right. Okay. Oh yeah. I guess unimodal versus bimodal versus. Okay. All right. So this would. Observations versus observational studies versus experiments. You should know that. Okay, just conceptual stuff. The empirical rule. What is the empirical rule? Okay, so how much of the data is within 1 standard deviation of the mean? Yeah, this is about 68%. What about 2 standard deviations? Okay, about 95. And 3 standard deviations? 99.7%, almost all. Okay, all right, let's talk about correlation. Okay, correlation tells us what? Yes, strength and direction. Basically a linear relationship. How can we tell if something's linearly related? You must make a scatter plot, right? Okay, the only way we can tell if something's linear is if there's a scatter plot. What's the range for R? Yes, a -1 is always less than or equal to R, less than or equal to 1. Okay, so R can be anywhere between -1 and 1, and it tells us the strength and direction. What is the what's a residual? Yeah, the actual or observed minus the predicted. It's kind of the difference between the reality and what we predict. And the least squares line tries to minimize the squared residuals, okay? So our best fit line tries to minimize squared residuals. I don't know why my S came out so funny here. I think that's it for chapter 4. Okay, so for probability, you should know what does it mean to be mutually exclusive? What does it mean to be independent? And how those things work out. I feel like that covers your pre-midterm stuff as far as conceptual things go. So I'd review the kind of definitions and those things. Any other questions? We feeling pretty good? All right, great. Okay, well, again, so for the final, you will get the formula sheet and the reference tables. Those will be provided. Just make sure you bring your calculator, pen or pencil, an eraser, and that should be it. Good luck as you guys study. And again, I would appreciate you guys leaving me a good student evaluation, I hope. And of course, any feedback is welcome. So good luck. We'll see you guys on Wednesday.